Hello all. I implemented the complete coverage algorithm using Bourne rectangle method. These are the CDP versus time graphs for both heat maps. We can see that the path is greedy. That is, the slope initially is very high. Uh, and coming to the efficiency, although the graphs are similar, you can see significant differences between both heat maps. Initially, for heat map 1, the efficiency is very low. And so to understand what happened, I plotted the graphs only up till t equal to 1000. And these are the graphs. Here you can see that up to t equal to 200, the CDP in path 1 increases slowly compared to path 2. Uh, this might be because it encountered only low probability nodes immediately after entering the boundary rectangle. But it catches up to path 2, and at t equal to 900, it's almost the same. The CDP is almost the same in both graphs. However, when I observe the efficiency, it's still lower than that of heat map 2. To understand this, I recorded the b values and observed that they're consistently higher for heat map 1 compared to heat map 2, even at t equal to 900. So both these reasons, like lower CDP initially and high b value, led to the poor efficiency of heat map 1. Coming to the algorithm, it can be considered as a search problem because it has all the attributes: the initial state, the goal state, the actions. We have a successor function, and also we can calculate the path cost. It can be considered as a greedy search because we are going for the high probability nodes first, and clearly it's not an adversarial search or a CSP. This is an example of a greedy search, and the algorithm I implemented is almost similar to the one talked about in the paper. It uses the same lawnmower pattern. The only difference is that I modified the bounding rectangle so that it contains all the highest probability nodes instead of the non-zero probability nodes. This will make the UAV path more greedy. To reduce the turns, I divide the rest of the area into four non-overlapping rectangles. Since they are non-overlapping, uh, it's it will reduce the number of turns UAV takes, but it's not completely efficient because I do not know which is the closest rectangle to the node I'm currently in, because I know I'll start at the left side of the bounding rectangle, so I'll end on the right side, but I do not know whether I'll end at the right bottom or the right top. So if I knew that, I would take the closest rectangle, and that will be more efficient in reducing the number of turns. Theoretically speaking, it would take the same time as almost the same time as the simple non-greedy lawnmower path. This is one way to reduce the number of turns.